Hello there, this is Tony Dubiel again, Technical Solutions Architect working for Cisco Cloud and Managed Services Organization. Today I will share with you a demonstration of Intercloud Fabric plus application management as a use case. Specifically, application lifecycle management leveraging Ansible as an application configuration management toolset to provide a mechanism to install applications, to update them, or to upgrade applications that reside within virtual machines, as well as providing capabilities to update or upgrade the guest operating systems. So in this demo, we will draw a clear demarc in a swim lane between the responsibility of the operations teams who manage the application configuration management toolsets with a scope specifically focused on the guest operating systems, as well as the applications as part of a virtual machine footprint, and then discuss the underlying infrastructure and delineate the responsibilities and complexity, as it were, to interoperate and internetwork a private cloud data center to a provider cloud, hence extending the enterprise private cloud into the provider cloud to leverage hardware resources and other infrastructure as a service capacity that is leveraged for virtual machines. Taking a step back and reiterating some of the focus in earlier video sessions on the use cases of Intercloud Fabric, a lot of focus and emphasis was made on the ability to migrate virtual machine workloads into a provider cloud, as well as the ability to upload specific images and create templates in Intercloud Fabric to make them available in the provider cloud to quickly spin up a net new instantiation of a virtual machine whenever we need to spawn additional copies of a virtual machine into the provider cloud. The reason why we do that is because in these images we are also packaging a guest operating system as well as an application. In other words, we're creating purpose-built virtual machines with a pre-installed application. Now what happens next? What happens as we have a need to upgrade an application or a guest operating system, or possibly fix an application needing to install a security update or another update to fix various anomalies in the application? How do we manage the life cycle of that application? I submit to you that Intercloud Fabric today does not cover the scope of any modifications to the application. However, Intercloud Fabric is an excellent facilitator of orchestrating and automating the ability to build the network infrastructure and to incorporate security underneath the application management platform to enable it to have full control of virtual machines that reside across multiple clouds that are connected together through Intercloud Fabric and the secure connectivity between the private cloud and the external provider cloud. Without a solution such as Intercloud Fabric, a application configuration management toolset such as Ansible would have to leverage the public IP and capabilities to connect over SSH on the front end to each one of these virtual machines. So what does that mean? That actually adds additional complexity to these teams in terms of setting up the Ansible service to connect to these virtual machines, because each one of those virtual machines is a touch point in terms of a security group that would have to allow for port 22 SSH or whatever port they modify SSH for in order for it to connect to each one of those virtual machines. Or as an alternative, the actual Ansible control point or Ansible tower, which is the paid and licensed version of Ansible with additional tool sets to provide policy-based management across virtual machines in terms of application management, whether it be the free command line version or the Ansible tower. Those control points would need to be installed in each one of these provider clouds. My assumption is that most customers would prefer not to manage multiple control points and to incur a hit on licensing in needing to manage multiple Ansible towers as an example. Clearly, the preferred alternative would be to simplify the connectivity to the clouds and make the provider cloud appear as an extension of the enterprise private cloud by extending that private IP addressing, allowing the Ansible control point to connect to the virtual machines on premise or in the provider cloud as if they were an extension of the private network, making the network a non-issue in terms of connectivity. Cisco, by its nature, is network-centric and a leader in providing internetworking capabilities, traditionally through hardware appliances and more recently through virtual appliances. In other words, virtual machines that can be orchestrated and provisioned and chained together logically to provide for functionality to make internetworking between clouds a reality. And not only can we connect these clouds together, in some cases we can enhance provider cloud environments by introducing features and protocols that are not natively supported in their existing infrastructure as a service. Some examples are multicast and ER-span. ER-span is the ability to capture live traffic. In Intercloud Fabric, we are able to extend those layer 2 LAN extensions, and ultimately we can sniff and capture that live traffic. To recap, the teams that focus on application configuration management as part of an application lifecycle management process are typically the same teams that are building the DevOps environments. They want to focus specifically on the applications, all of the details and the minutia of the underlying infrastructure and the network and security, all of that. Those are issues for the network teams and the security teams. Now, for those teams, if you were able to offer them an automated alternative to make it very easy to implement the network and the security, then perhaps some of those would be the same personas that would start to look into delivering applications. It's potentially a career migration, moving into application delivery and focusing on optimizing that aspect of the IT responsibility, for providing resources to the lines of business versus focusing on some of the more traditional aspects of network and cloud connectivity. Just food for thought. Now I'd like to show you a quick overview of the lab layout and some of the virtual machines that we will focus on as part of the demonstration. As you can see here, we have two clouds, Microsoft Azure and AWS, Amazon Web Services EC2. I have a connection, a secure connection from Intercloud Fabric into both of them. Today we will focus on an application server at 192.168.11.21 that is part of an AWS application VDC, Virtual Data Center, that we've provisioned in Intercloud Fabric, as well as a virtual machine as part of a Q&A environment that we've provisioned in Microsoft Azure at 192.168.2.5. Both of these being private IP addresses and separate VLANs that are layer 2 LAN extensions that have been extended across both of these tunnels into both of these provider clouds. That Ansible, which has been installed in the enterprise data center, both the free command line version as well as the Ansible Tower, which is the GUI and paid and licensed version of Ansible that also includes group-based policies, roles-based access, the ability to orchestrate and provision jobs of running multiple playbooks, which allows for the operations teams to automate those updates and those upgrades that they manage as part of ACM. That will have connectivity to both of these clouds and to these specific virtual machines to be able to update and upgrade them or to install additional applications using the Ansible platform. Okay, now let's look at a virtual machine that was installed in my lab that represents the customer's private data center. And in this virtual machine, I installed the free version of Ansible. So we're not going to go into those details, but I did need to install it. So I'll provide you with a link that has the process of installing Ansible into, in this case, Linux on a virtual machine, as well as importing the private key of the Ansible control point into the virtual machines and guest operating systems that you would like to manage. So in order to do that, we need to create a host file. So we'll take a look at that quickly. All right, so this is a host file. If we want to edit it, we'll use the VI editor, and I will do that. So insert. And then after we hit I for insert, we can go in here and edit the file. So Intercloud is the actual group. You can see we have other groups in here that have been commented out by using the pound sign. And they would not be processed as part of the host file. If we use the command all, it would look at every IP and group that is not commented out, and it would connect to those. So in this case, everything has hash mark, so it's commented it, and this one's not. So this one in Intercloud is a group in brackets, and then these are the IP addresses that happen to be the private IP addresses that represent the enterprise that have been configured in Amazon and in Azure. So this 198.168.10 should be at .11, so we'll change that. And this is a virtual machine running as an application server in AWS. And this is 192.168.2.5, which is the QA virtual machine that's running in Azure. So both of these are Linux operating systems, and we'll see that as we make updates. So I'm going to go ahead and escape, and then :WQ to save this file. Okay, and we can test to make sure that connectivity is working. Let's test with a ping, an Ansible ping. Make sure we have connectivity. Okay, so we've connected to both of those virtual machines, leveraging the network connectivity of Intercloud Fabric. As Ansible as a control point is completely unaware that it's communicating across multiple clouds. It just sees them as an extension of the local network and the reachability that is provided to it. So the next thing we want to do is we want to look at what we call a playbook. So a playbook is the actual script that we will launch from Ansible to accomplish something. So, regarding the capabilities of Ansible, primarily it's focusing on either updating software or an application or installing a new application. So in this case, we will update an existing application, which happens to be the web server. So we'll take a look at the Apache web server, and if it needs to be updated, then Ansible will provide that workflow to orchestrate updating that particular application. So let's take a look at the playbook. Okay, and that's what we're doing here is we're calling the host file Intercloud. It will pull these IP addresses from the host file, and then we're going to go ahead and update Apache if needed. Okay, so now we need to launch the playbook itself. Playbook. All right, and then the name of the playbook. Playbook 1. Okay, and verbose so we can have more details in success or failure of a particular task. We can see all packages have already been updated to 192.168.2.5. 11.21 is taking a few moments, so more than likely it's updating some files, so we will wait on that piece. Okay, we have an indication that the files have been changed. There was an update to the second server, the 192.168.11.21. Went ahead and downloaded a bunch of files to update the Apache web server, and that's what we can see happen here in yellow. 11.21 in Amazon was changed. 2.5 in Azure was okay. It was already previously updated to the latest version of the Apache web server. So now we'll go ahead and run it again, and what we should find is that both of these servers are now updated, so there's no reason to update them with additional files. And that is the case. Now, you are looking at Ansible Tower, which is the paid and licensed version of Ansible. So where this solution goes beyond what we looked at in the previous Ansible command line tool set is that it provides the ability to orchestrate and automate the provisioning of those playbooks by creating projects. So projects is where we establish how we would like to use the playbooks, or we can perhaps nest multiple playbooks into a project. It also gives the end user a high-level view of all the jobs, scheduling of jobs, whether they were successful or not. It provides them with that historical data, so it is a much more robust operational platform than leveraging the free version of Ansible. So let's just take a look at the jobs that we create leveraging playbooks. So if we go to templates, we can see that I use playbook 1, which was saved on the server, and I have access to those playbooks from the Ansible Tower, and I can obviously connect over the Intercloud Fabric Director to the virtual machines that we would like to update or manage in terms of operating systems and applications. In terms of the configuration of Ansible Tower into my lab, I have it configured on a virtual machine with a 10.42.0.42 address. However, I'm using a router in my lab to be able to route to the 192 addresses. So you can see from an inventory perspective that I'm connecting to the 192.168.11.21 in AWS and the 192.168.2.5 in Microsoft Azure. And I'm able to do that because my local area network has routability into the 192 subnets that are LAN extensions that are enabled by the Intercloud Fabric, specifically the secure fabric connectivity, and that is completely transparent to the Ansible tower, who sees those virtual machines really as an extension of the local network that it has reachability to, and otherwise would have no details of all the complexities underneath that to interoperate and stitch those networks together. So if we were to look at the job templates that we've created, are based off of playbooks. Playbook 1 is the same playbook that we launched from the command line. We can orchestrate it, obviously from the tower by configuring projects that include specific playbooks, and then job templates that we can use to launch jobs that include these projects in playbooks, or nested playbooks within projects, or multiple playbooks stitched together with projects. From a jobs perspective, we can launch a specific playbook, and we can see, obviously, track the status. So if we launch a job, we need to have the SSH key. Or we could have configured this to automatically include the key, as part of a project as well. So we'll go ahead and launch job 12 and refresh that one. It's running. And it completed. So if we go back to the dashboard, we can see job ID 12, status of green for successful. And this is a part of the, that high level dashboard that is used by the operations teams.